Welcome to this episode of Robert's Creative Chronicles. So today, we'll be solving this question, which says that find the Thevenin voltage, the Thevenin resistance, and the load current and the load voltage flowing through RL resistor. That's the load resistor, as shown in the figure below using Thevenin's theorem. So here is the circuit. So solution. Now, since we are to find the load current and the load voltage, that is RL, this is the load. That means we'll remove, according to Thevenin's theorem, we're going to remove this branch, since it's this point that we're going to find, and we'll name it AB, the terminals. If the questions could have specified that we should find the current and the voltage maybe across 8 kilo ohm resistor, we could have removed this branch from here to here. We could have removed it. But the question says we should find the load current and the load voltage. That is, and this is the load. So it's this branch we are going to remove. So when using Thevenin's theorem, the resistor that are to find the current and the voltage, that's the resistor you remove. And you rename the terminals AB. So when we remove this branch, since we are finding the load current and the load voltage, the circuit becomes here is 12 kilo ohm, here is 48 volt, here is 8 kilo ohm, here is 4 kilo ohm. So now we are going to find the Thevenin voltage and the Thevenin resistance. Now, the Thevenin voltage is the open circuit voltage here. So the voltage here is the Thevenin voltage. And also the resistance, the equivalent resistance between these two terminals is the Thevenin resistance. So let's start with the voltage. To find the voltage across here, across these terminals, these two terminals, according to Thevenin's theorem, we are going to, you know this is a voltage source. So current will flow from here and enter this terminal. It will enter 12 kilo ohm resistor. When it comes to this point, all the current will enter 4 kilo ohm resistor. No current will enter 8 kilo ohm resistor because here is an open circuit. There is no current that will flow here. So, and when there is no current here, the voltage here will also be zero. So the current and the voltage here, everything is zero. So this, there's no current here. So this, like, there's nothing here. So 12 kilo ohm resistor will be in series with 4 kilo ohm resistor. Normally, if this here was closed, the current when it comes here is supposed to split into two. So 4 kilo ohm resistor is parallel, would have been, so 4 kilo ohm resistor would have been parallel to 8 kilo ohm resistor. But now, since there's an open circuit, no current comes here. All the current will enter here. So this and these two resistors are in series. So since they are in series, the resistance becomes 12 plus 4, which is equal to, that is the equivalent resistance, which is 16 kilo ohm. And this is the voltage. So to find the current is equal to voltage over resistance, according to Ohm's law. So it will be 48 over 16 is 3. And there's a kilo here. This is 48 volts divided by 16 kilo ohm. So it's like 48 divided by 16,000. So this 48 divided by 16 is 3. Then 1 divided by 1,000. 1 divided by the 1,000, which is 1 over kilo, is milli. It's 10 raised to the power minus 3, which is milli ampere. This one is 1 over k. That is 1 over 1,000. 10 raised to the power minus 3. So this is the current flowing through this circuit. Now, to find this Thevenin, which is the open circuit voltage, if we find the voltage across this 4 kilo ohm resistor, we have found Thevenin. So we need to find the voltage across this ohm resistor. Then that is the voltage here at this point. So the voltage at this point is also the same thing as voltage at this point. That is in this circuit. Since this resistor, this 8 kilo ohm, since this 8 kilo ohm resistor circuit does not exist because of the lack of current. So the current here is 0, the voltage here is also 0 at this point. In this resistor. So the voltage and the current in this resistor is 0. So now the voltage in this 4 kilo ohm resistor is V is equal to IR, which is equal to 3 times 4, which is, this is 3 milliampere and this is 4 kilo ohms. So this milli and kilo, they'll cancel each other. 10 raised to the power minus 3 and 10 raised to the power 3, they'll cancel each other. So it becomes 12 volts. So Thevenin is equal to 12 volts. So we have successfully found the Thevenin voltage, which is equal to the open circuit voltage, as 12 volts. So Thevenin is 12 volts. Then, so we have successfully found the Thevenin voltage as 12 volts, which is the same thing as the open circuit voltage. Now, to find the Thevenin resistance, we need to short circuit all voltage sources and open circuit all current sources. In this circuit, there's only a voltage source, so we'll short circuit this. It becomes so this becomes 12 kilo ohm, 8 kilo ohm, 4 kilo ohm. And this has been short circuited. This voltage source. If there were current source, we could have open circuited it. So now we are going to find the Thevenin resistance, which is the same thing as the open circuit resistance. So we'll look at this terminal. This resistance will be calculated when looking from here. So when we look at here, when there is current source and the current source is passed through here, terminal A, the current will enter here, and when it comes to this node, it will divide into 2. So this and this are parallel since different currents enter them. Since the current splits and different portion of the current enters, so these two are parallel. So this will be 8 kilo ohm plus 12 kilo ohm parallel to 4 kilo ohm. So now the Thevenin resistance will be equal to 8 plus, since there are two resistors in parallel, to be product over sum, so it's 12 times 4 over 12 plus 4. Twelve times 4, 12 plus 4. This is 3. So this is equal to 8 plus 3. So the Thevenin resistance is now 11. So the Thevenin resistance is now 11 kilo ohms. So now we can redraw the circuit to get our Thevenin's equivalent circuit. So here is the Thevenin's equivalent circuit. Here is Thevenin. Here is the load resistor, RL. From the equation, RL is 5 kilo ohms. Here is the R Thevenin. So now, according to Thevenin's theorem, that circuit can be replaced with a voltage source connected in series to a resistance. So this is the voltage source, which is the Thevenin voltage, and the resistance, which is the Thevenin resistance. And we have calculated them. So the Thevenin voltage is what? 12 volts. So here will be 12 volts. And the Thevenin resistance is 11 kilo ohms. The Thevenin resistance is 11 kilo ohms. And these are two terminals, A, B. You know, the question stated that we should find Thevenin, Thevenin, and the load current and the load voltage. We have found the voltage, the Thevenin voltage and Thevenin resistance, that is Thevenin and Thevenin. So now remain the load current and the load voltage. So since we remove the branch, according to Thevenin's theorem, to solve it, now since we remove the branch according to Thevenin's theorem to find the load current and the load voltage of that branch that we removed, now we have put it back so that we will find the current and the voltage. And this is how you do Thevenin's theorem. You just specify, you remove that branch, you just say you should find the current and voltage across a resistor that is attached to a branch. You remove that branch, then you put it back after finding the Thevenin voltage and the Thevenin resistance. Then now we can find the load current and the load voltage. So these two are in series. So the equivalent is 11 plus 5, which is 16 kilo ohms. So now current equals to voltage over resistance. So this is the voltage 12 over the resistance 16 kilo ohm. That will be 12 divided by 16, which is 0.75. Which is 0.75. So this is 0.75. And you know there's a kilo here. So 1 over 1000 is milli. So it's milliampere. That is 10 raised to the power of minus 3 ampere. So, and you know that since these two resistors are in series, the same current will pass through two of them. So we can say that our load current, which is IL, is equal to 0.75 P small letter m milliampere. Now, to find the voltage across this one, we will use V is equal to IR, Ohm's law. So we have the current, that is, we'll say VL, the voltage across the road. Now the current is 0.75 times the resistance is 5. No, you know this is milli. This is milli. This is kilo. So milli times kilo is what? Will cancel each other. That is 10 raised to the power of minus 3 times 10 raised to the power of 3. They'll cancel each other. So this becomes 0.75 times 5 is 3.75. then it will be volt. So it's 3.75 volts. So the voltage across the load resistor, which is 5 kilo ohm, is 3.75 volts, and the current is 0.75 milliampere. So we have found all the parameters that was asked in the question. I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email it in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.